Hello, Geometry. Welcome to 4.7, take 2. Just got done with Blaze's last baseball game of the season. Enough of that. All right, 4.7, use congruent triangles. And this is the part where I've been telling you the acronym CPCTC. Don't you forget it. This is going to be fabulous. You're going to actually like this in the long run. So we have joining us is Timmy, the mouse. Kind of for Halloween, I guess. Okay, Timmy's going to just hang out over here. All right, so let's get started. I can use congruent triangles to prove corresponding parts are congruent. So basically that's what the CPCTC is. Corresponding parts of congruent triangles are congruent. So once you tell me that two triangles are congruent by such as side, 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 angle, angle, side, angle, 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 side, and good old hypotenuse leg. So for each one of these, you need three things. Even this one, you have to prove that you have a right triangle. You need three things. And once you have three things, the triangle that are congruent, that means the other three corresponding parts of those triangles are also congruent. So that's actually a really important word here, corresponding. You don't want to miss that, okay? I always find it entertaining when students are using CPCTC because they'll just have like random C's and P's and T's as their reason, and not in this exact order, but try to keep this correct. Here we go. Suppose that triangle XYZ is congruent to triangle RST. So in that order, XY, that's like these two right here, would be congruent to segment RS. Angle Z is the last one. It's congruent to angle T. Look at this. The measure of angle S is going to be equal to the measure of, S is the middle, angle Y. Okay, I already wrote the measure of angle. All right, and then this doesn't correspond to that congruent statement. So here, angle A is congruent to angle B. The measure of angle A is 2x plus 40, set it equal to the measure of angle B, which is 3x minus 10. We want to find x, so we're going to solve for x. I'm going to subtract 2x on both sides. You'll have 40 is equal to x minus 10, then add 10 to both sides. X is equal to 50 degrees. So far, so good? Okay, here we go. CPCTC. We're going to decorate this. Maybe put a heart, star, however you want to decorate it. All right, so, you know what, it's not looking like a red pen. Maybe that does, that too bright. Okay, so that's my red pen. Here we go. Congruent triangles. So once we know that these are congruent, for instance, this triangle is congruent to this one by angle, side, angle. I don't like how they have one arc for both of those. When you put one arc for both of those, you're saying that these two are the same and they don't really look like it. In any case, angle, side, angle. So I put two arcs for both of these. There we go. Now, congruent triangles have congruent corresponding parts. So if you can prove that two triangles are congruent, so that's always your first step. Try to get one of these. Then all the remaining corresponding parts, and that's the most important word, are also congruent. So looking at these two triangles, this is the congruence statement by angle, side, angle. Now, we have this information, so we now know that angle W is congruent to angle N. OW, which is this segment, is congruent to AN. Go in the same order. See, AN, OW. And WB is congruent to NM. That's segment. All right, so far so good? Now, there's not a lot on these pages, so this should go pretty fast. All right, complete the proof. So this one kind of looks like a kite. I like these proofs. If you can read this, this is A, B, C, D, and E. All right, so AC bisects angle DAB, so it cuts this angle in half and it cuts that angle in half. That's given. Now, what does an angle bisector do? It's going to make this angle equal to that one. So here we have DAC is congruent to BAC. Okay, that's that part. And then it's also going to cut this angle in half. DCA is congruent to BCA. Why? Because definition of an angle bisector. Remember, always try to pull out what was from prior. Okay, starting to get a glare. Oh, yeah, the glare's too bad. Okay, so now, look at this statement. Remember I told you this would pop up a lot? AC, that's this whole length, is congruent to itself. Reflexive. Look at that top triangle. And the bottom triangle. Obviously not to scale. What I have is this, this, and this. Is the top triangle congruent to the bottom? Yes. By what? Angle, side, angle. Remember the side is included, meaning in between the two angles. Okay, so here's your congruent statement. Now, if your two triangles are congruent, then all the parts are congruent. So is DC, this segment, congruent to BC? Yes, by C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Or you can write that out, but have fun with that. All right, example 2. I now have a little picture. This is a bowl. That's a bowl. There's this pasture. We want to know how wide it is, okay? We know how long it's almost going to be, it's going to be over 60 because this part is 30, this part's 30. We don't know that or that, but that's okay. We just want to know the width. Not sure why. Okay, here we go. MN is perpendicular to MP. So MN is perpendicular to MP. That's going to give me a right angle. RS is perpendicular to PS, and that will give you another right angle. Okay, so remember, perpendicular lines will give me right angles. Then we know that P is the midpoint of MS, so that's already marked. Okay, so a midpoint will cut those two segments in half, so these are congruent. And we want to find this width. All right, so we put all the given information together. I think in the past I had it separated, and I don't have enough space in the bottom, so I put them all together. Now, what do perpendicular lines do? They give me 4 right angles. So perpendicular lines equal 4 right angles. So if you're not sure if it's a definition or a theorem or a postulate, just write it down what it is. That's good enough. Okay, now angle NMP is congruent to angle RSP. Because if you have 2 right angles, they're congruent. So all right angles are congruent. What do we have now? MP is congruent to SP. We found that out before. That was because of our midpoint. So definition of midpoint. Now look, this triangle is congruent to this one. Why? Oh, we got one more thing here. MPN, that's this angle, is congruent to this. Why? What are those angles called? Vertical angles. Vertical angles are congruent. Now this triangle is congruent to this one by angle, side, angle. Now, if the top triangle is congruent to the bottom one, that means all its corresponding parts are also congruent. This angle is going to be the same as this one. This side will be the same length as that. And these two sides will be congruent. So RS is congruent to NM by CPCTC. So when you're looking for parts of triangles that are congruent, that's usually going to be your last step, about 90% of the time. And right before it will be a triangle congruence. So what's the width of the bull pasture? 40 feet. That's actually not a lot. I probably should change the numbers in the future to make it seem more realistic. Otherwise, PETA will be on me. All right. Ooh, look at this one. There's a reason why I said write a plan for the proof, just because this would be a super duper long proof, and I don't have a lot of space here. So I made it a plan, and here we go. Given angle 1 is congruent to angle 2, that's right here and right there. Angle 3 is congruent to angle 4. Okay, so angle 1, this is angle 1 right there, and this is angle 2 right here. Okay, so those are congruent. Now we also know angle 3 is congruent to angle 4, but once we know we have a linear pair, they're supplementary, okay, So when you have a linear pair supplementary, they both add up to 180. If these two are the same, that means these two will be the same. All right, so we know that angle 5 is going to be congruent to angle 6. Because the supplementary angle congruence. So that means this angle, which is 5, let me put 2 arcs right there, is going to be congruent to this one. All right? Oh, let me put a line like that. Okay, so I have those 2 angles. Now, let's put 2 right there. MN is congruent to MN. Why? That's reflexive. So is one triangle congruent to the other? I have angle, angle, side. So yes. These are congruent. Okay, now, if they're congruent, are parts congruent? Okay, now I know this is weird because what we're looking for, I wish I had a colored pencil handy. MNR, I'm looking for, R is in the center. I want to know if this triangle is congruent to this one. Okay, but if you'll notice, I have an angle here. I know I'm going to have this angle right there because of vertical angles. But I don't have any side lengths. However, look at this. This side length is congruent to this one. Why? Because of CPCTC. So I can mark that right here. So now this triangle is congruent to this one by angle, angle, side. Very tricky, and hopefully you understand why I didn't make this a big giant proof, but I want you to start paying attention to this. We had to prove 2 different triangles to get a part to prove 2 other triangles. Okay, so these can get complex. Alrighty. Proof of construction. This is actually a nice, really cool construction here. Here we go. Lots going on here. AB is congruent to AD, which is congruent to CD, which is congruent to CB. Okay, obviously those are, when it says construction, those are probably all arc lengths. So a radius of some sort. And that would all be given. Given. Okay, now BD, that's the whole middle length right here, is congruent to itself. Reflexive. I'm going to put 2 lines there. And look, this triangle on the right, or sorry, the left, is congruent to the triangle on the right by side, side, side. Now, if the triangles are congruent, that means all the parts are congruent. So ABM, that's this angle, has to be congruent to CBM. Okay, by CPCTC. And then look at this. BM is congruent to itself. So again, that will be reflexive. And look at this, the top triangles right here. The top left and top right. Side, angle, side. Now, if that is congruent to this, then MA is congruent to MC. Whoopsie. Fix that. How did I miss that? MA is congruent to MC. Why? CPCTC. If these 2 segments are congruent, then this has to be the middle. So that's their midpoint. Whoops, definition of midpoint. Alright, that's the end of the video. Hopefully it recorded this time. Here's our homework assignment and our Common Core standards. Everyone have a nice evening, and hopefully I will thaw out soon.